Right, good morning. Day 4, density problems. So I'm going to definitely need a calculator for these. Just a little reminder, density, density is mass over volume. Okay, so remember that. Right, let's have a look. Density of apple juice is 1.05 grams per centimetre cubed. Density of fruit syrup is 1.4 grams per centimetre cubed. The density of carbonated water is 0.99 grams per centimetre cubed. 25 centimetre cubes of apple juice are mixed with 15 centimetre cubed of fruit syrup and 280 centimetres cubed of carbonated water to make a drink with a volume of 320 centimetres cubed. Work out the density of the drink. Give your answer correct at 2 decimal places. Right. This sounds difficult, and looking at it, it is, but it's just the way that you set it out. So it's working out exactly what we've got. So we've got density, we've got apple juice, we've got fruit syrup, we've got carbonated water, and the apple juice mixed with the fruit syrup and the carbonated water to make a drink. Okay, so what we've got is we've got the 3 components. So we've got apple, we've got fruit, we've got water, and then we've got the drink. So this is one way of doing it. And then as such, we've got to realise that we've got density, mass, and volume. So, doesn't matter which order you put those in. You might do density at the top, then mass, then volume. Sometimes I do the table the other way around, but a table with these is usually easier. So, I'm going to put my working out. Okay, now the one thing you understand is that you can add volumes together, you can add masses together, but you can't add densities together because they're a combination of the other two. So always remembering we can calculate mass and volume if we've got other things. So let's put some values in. Density of the apple juice is 1.05. Density of the fruit syrup is 1.4. Density of the water is 0.99. We can't just add those together to get the density of the drink. Okay, what we've got then is 25 centimetres cubed. So centimetres cubed is a volume. Oops, let's rub that out. So we've got 25 centimetres cubed of apple juice. We've got 15 centimetres cubed of fruit syrup and 280 centimetres cubed of carbonated water. And if we add those together, they've told us that the drink is 320, which is great. So all we've got to do is work out the density of the drink. So as such, I just need to work out the masses and then add the masses together and then just do mass divided by volume. So not actually that hard. Looking at this, to find the mass of anything, it's density times volume. So to get the mass of the apple, it is just 1.05 times 25. The density of the fruit drink is 1.4, so that's times 15. And then the water is 0.99 times by 280. So I've got my calculator today. I know you can't see it, but 1.05 times by 25 equals, yesterday on that, 26.25. 1.4 times by 15 is 21, and 0.99 times by 280 equals 277.2. So as these are all masses, just weights for if you want, we can just add them together. So I've got 277.2 plus 21 plus 26.25. That gives me 324.45. Now I just want to find the density. So the density, if I'd done across this one out, density is mass over volume, and in this case it's 324.45 divided by 320, which is 1.013, which is 1.01. 1.01. Yep, that's great. Grams per centimetre cubed, if it didn't have it on the question, but it does. There you go. Actually, when you look at that question now, it's not as bad as it looks, just how you set it out. Always get that formula right. A lot of people get that mass and density the wrong way round. Second question. Density of ethanol is 1.09 grams per centimetre cubed. Density of propylene 0.97 grams per centimetre cubed. 60 litres of ethanol mixed with 120 litres to make 188 litres of antifreeze. Work out the density of the antifreeze. Give your answer correct to 2 decimal places. Similar type question really. So what we've got from last time, we had, so we've got ethanol, we've got propylene, and we're going to make antifreeze. We've got density, we've got mass, and got volume. Doesn't matter which way round you do these, it's just a way of seeing the information. Now, so first of all, the density is 1.09 grams per centimetre cubed. Okay, 1.09 grams per centimetre cubed. Density of the propylene, 0.97 grams per centimetre. Then we're talking about litres. Now, what we've got to remember is that, in fact, how many centimetre cubes are there in a litre? Well, in fact, 1 milliliter equals 1 centimetre cube. So 1 litre equals 1,000 centimetres cubed, because a litre is 1,000 millilitres. So in this case, I've got to change all of these. So what I've got is I've got 60 litres, which is a volume. So what I've got is 60,000 centimetres cubed. I've got 128 litres, which is 128,000 centimetres cubed. And much as before, to get the mass, density is mass over volume. To get the mass, it's density times volume. So I've got 1.09 times by 60,000. 1.09 times by 60 is 65,400. Then what I've got is I've got 0.97 times by 128,000. 0.97 times by 128,123 is 124,160. I can add those volumes together. That's 188,000 centimetres cubed, and I've got let me see, 65,400 plus 124,160 equals 189,560. And then once again, density is mass over volume. So I've just got that divided by 188,000 equals S to D 1.008, so it'd be 1.01. And if you think about it, usually when you're mixing things up, the densities are somewhere in between. As there's a lot more of the propylene, it's probably bringing that sort of average idea down. Okay, good. Next one. So Jackson is trying to find the density in grams per centimetre cubed of a block of wood. The block of wood is in the shape of a cuboid. He measured the length as 13.2 centimetres, correct to the nearest millimetre. The width as 16.0, correct to the nearest millimetre. The height as 21.7 centimetres, correct to the nearest millimetre. He measures the mass as 1,970, correct to the nearest 5 grams. By considering bounds, work out the density of the wood, give your answer to a suitable degree of accuracy. We'll show you work and give a reason for your answer. Okay, so we've got a bounds question. So the first thing is, I'm going to have write my bounds. So nearest millimetre is 0.1 of a centimetre. So first of all, up here, I'm going to have length, and that is just the 0.1 is 13.15 and 13.25. For width, that is 15.95 and 16.05. And for height, that is 21.65. Can't write today. 21.65 and 21.75. So just always make sure you get your bounds right. And then you get a mark just for getting one of those right. Then we've got the mass. Now some of you struggle with this one, and because it's to the nearest 5, you actually go 2.5 either way. So the upper bound is 1972.5, and then if we take 2.5 off, we've got 1967.5. Yeah, that 5 grams, just take 2.5 off either side. Right, so what I've got here is it's trying to find the density. So I already know that density is mass over volume. So I'm going to have to work out the volume, and what I've got to do here, because it's suitable degree of accuracy, I've got to find the upper bound of the density and the lower bound of the density and compare them. So if I do the upper bound, say, density upper bound, the density upper bound, when you're trying to find the biggest value, that is the mass upper bound divided by the volume lower bound. So the mass upper bound is 1972.5, and the volume lower bound is all the lower values multiplied together. So I've got 13.15 times by 15.95 times by 21.65. Okay, and that will give me, if I did all that in one go, 197.2.5, go down. Note I just use brackets, saves me using times all the time. 13.15 times 15.95 times 21.65 gives me 0.43438. So I'll do it to 5 decimal places. Usually these don't go that far. If I then do the density lower bound, what I've then got is the mass lower bound divided by the volume upper bound, and that's how you get the smallest possible value. In this case, the mass lower bound is 1967.5 divided by, and then I've got all the upper bounds, so I've got 13.25 times by 16.05 times by 21.75. Once again, my calculator, 1967.5, and I've got 13.25, I've got 16.05, I've got 21.75, and that gives me 0.42536. Okay, I've done that to 5 decimal places. Now what we've got to do is just compare these it says appropriate degree of accuracy. So in this case, because it's we can work to decimal places, I think. So first of all, we compare the two. So we've got 1, if we do 1 decimal place, we've got 0.43438, and we've got 0.42536, and to 1 decimal place they are both 0.4, so that could be an answer. We want to be maybe a little more accurate, so we've got 0.43438, 0.42536. If I go 2 decimal places, I can see that the 4 keeps the 3 the same, but the 5 rounds the 2 up to a 3, so they both round to 0.43, so that's better accuracy. If I do 3 dp, then I've got 0.43438, 0.42536, 3 dp, I've got 0.434, and I've got 0.425, so that doesn't work. So both round to 0.43 to 2 decimal places. There you go, done. Here we go, liquid A and liquid B are mixed together in the ratio 2 to 13 by volume to make liquid C. Liquid A has density 1.21 grams per centimetre cube. Liquid B has density 1.0 grams per centimetre cube. A cylindrical container is filled completely with liquid C. The cylinder has radius 3 centimetres and height 25 centimetres. Work out the mass of the liquid in the container. Give your answer correct to 3 significant figures. You must show all your working. Okay, we've got a bit of work here. So we've got, how did we do it before? So we've got liquid A, we've got B, and we're making liquid C. Same as before, we've got a density, we've got a mass, and we've got a volume. This table's serving me well. Density of A is 1.21, density of B is 1.02. Right, so liquid A are mixed together in the ratio 2 to 13 by volume to make liquid C. So now I've got to look at the volume. So cylindrical container is filled completely with liquid C. The cylinder has radius 3 centimetres and height 25 centimetres. So what I need then is to find the volume, first of all, of C. So volume of a cylinder is pi r squared, which is the circle, times by the height. So I've got pi, I've got radius of 3 squared, and the height is 25. I'll put that into my calculator. It's going to give me 9. It should be 225 pi. So I've got shift pi 3 squared. Oops. 25. Yep. So that gives me 225 pi. To be perfectly honest, leaving it in terms of pi saves me messing around with the decimal. So I'm just going to put 225. Now I've then got to work out this the volume of A and B. Well, if we look at it, I've got the A is 2, B is 13, and add those two together to make C gives me 15. I want that to be 225 pi. So what's the multiplier? Well, 225 pi divided by 15 is 15 pi. So 225 pi divided by 15 equals 15 pi. So all I'm going to do is times all of these by 15 pi. 2 times 15 pi is 30 pi. There's my 30 pi there. And then 13 times 15. 13 times 15 equals 195. It's got 195 pi there. So, remind me that density is mass over volume. So to find the mass of these, I'm just going to times the 1.21 times by 30 pi. So I've got 1.21 times by 30 shift pi equals 114.04 to 2 decimal places. And then I've got 1.02 times 195 pi. 1.02 times 195 pi is 624.86 to 2 decimal places. Add on 114.04 to get the mass of the C, which is 738.90. And then all I'm doing is density divided by mass. So density is mass divided by volume. So 738.90. So I'm actually just going to put a divide there. Divide by 225 pi equals 1.045. 1.045, and it wants 3 significant figures. The first 3 is there, which becomes 1.05. 1.05 down there somewhere. Okay. Right, that's that one. There's a lot of work here today. Gold bar has a mass of 12.5 kilograms. Density of gold is 19.3 grams per centimetre cubed. Work out the volume of the gold bar. Give your answer correct to 3 significant figures. Of course, this question is purely about the units. So, first of all, we've got density equals mass over volume. I want to find the volume. So volume equals mass over density. My density is 19.3, and that's grams per centimetre cube. Now my mass unfortunately is in kilograms, so 12.5 kilograms times by 1,000 equals 12,500 grams. So that's what I want this to be, because it's got to be the same units as the density, so 12,500. So what I've got is 12,500 divided by 19.3 is 647.66, which in three significant figures is 648 as a 3, and the units for this, for volume, will be centimetres cubed, which gives me the one. Good, it's quite easy. Liquid has a density of 1.42 grams centimetre cubed. 7 centimetres cubed of liquid A is mixed with 125 centimetre cube of liquid B to make liquid C. Liquid C has a density of 1.05 grams per centimetre cube. Find the density of liquid B. Give your answer correct to 2 decimal places. Similar thing that we've already had. So we've got density, we've got A mixed with B to make C. I've got density, mass and volume. Density is mass over volume. Oops, not a very good table. So, liquid A, 1.42. Once again, just remember you cannot add or subtract the densities. You can add volumes and masses and subtract them as appropriate, but you cannot do that with the densities. So 1.42 grams per centimetre cubed of A. Liquid A, the 7 centimetre cubes, that's 7 centimetres cubed is volume. B is 125. I'm going to get all the information in there first. Liquid C has a density of 1.05. Find the density of liquid B. Right, first of all, I can add 7 plus 1.25. I can add volumes to get the new volume, which is 132. Then what I've got here is mass is density times volume. So what I've got is 1.42 times by 7. 1.42 times by 7 equals 9.94. So that's the mass of A. B, I haven't got anything to work with. However, with C, I can do 1.05 times by 132. 1.05 times by 132 is 138.6, 138.6. So I've now got the mass of C. I can work out the mass of B by doing, if I do 138.6, take 9.94. Because it's a mass, I can take one off to find the smaller one. So I've got 138.6, take 9.94, and that gives me 128.66 mass for B. To find the density, once again, so density is mass over volume. So in this case, I've just got 128.66 over 125 divided by 125 equals S to D 1.029. 1.029, 2 decimal places, 1.03. That's a lot of questions today. one. Here is a frustum of a cone. That's basically a cone with the top cut off. The diagram shows that the frustum is made by removing a cone with height 3.2 centimetres from a solid cone with height 6.4 centimetres and base diameter 7.2 centimetres. The frustum is joined to a solid hemisphere, which is half a sphere of diameter 7.2 centimetres to form the solid S shown below. The density of the frustum is 2.4 grams per centimetre cubed. The density of the hemisphere is 4.8 grams per centimetre cubed. Calculate the average density of solid S. Okay, so we've got a volume question really. So let's set this up as we had before. So we've got the frustum. We've got the hemisphere, and we've got the solid, we'll call it. Okay, we've got density, mass, and volume. Okay, what do I know? Density of the frustum is 2.4. Density of the hemisphere is 4.8. Now what I need to do is work out the volumes of these. The frustum, essentially we've got to look at compare the sizes here. Because this is half size, in fact this will be half size as well, because it's just because they're similar shapes. So this is half of the whole, so this width will be half, or the diameter will be half of the big diameter, so that is 3.6. If we look at the cone, volume of the cone, it is just 1/3 pi r squared h. So with each one, so to get the frustum, I just do the volume of the big, which is 1/3 pi r is half of 7.2, so that's 3.6 squared times by the height in this case, which is 6.4. And if I put that all in, 1/3, 1/3. You could do this basically in one line on the calculator, but we're doing a bit at a time. 1/3 pi, I've got 3.6 squared times by 6.4. Brackets are very useful. That gives me 86.8587.5. Got quite accurate. Then if I go the volume of the small, that's just 1/3 pi. Half of 3.6 is 1.8, because that's the radius squared. The height is 3.2. Then I've got 1/3 pi 1.8 squared times by 3.2, and that is 10.85734. Volume of the frustum is just that, take that. So I've got 86.85875 minus 10.85734, 76.00141. So that's the volume of the frustum. 76.0014, and then the hemisphere is literally just half of the sphere. So I'm going to do it, I haven't got any space, just do it here. Volume of the hemisphere equals a third pi r squared, where the radius is 3.6. What am I doing? I'm doing the wrong one. 4/3, sorry. 4/3 pi, radius is 3.6 cubed. I've then got to remember I've got to halve that, so I'm just going to put 0.5 on the end, halve it in one go, and that gives me fraction 4/3 shift pi 3.6 cubed. Use my little power button. And then I've got 0.5, so I'm doing the half in one go, which gives me 97.716. 97.716. 97.716. If I add those two together, plus 76.0014, put an add in there if need be, it gives me 173.717, three decimal places. Then all I've got is my mass, just remembering that density is mass over volume masses, so just times these together, 2.4 times 76.0014, so 2.4 times 76.0014 equals 182.40336. Then I've got 4.8 times by 97.716, 4.8, sorry, 4.8 times by 97.716, that gives me 469.0368, add those together, add 182.40336 equals 651.44016, and then mass divided by volume for the density, so I'm just going to put a divide in here. Divide by 173.717 equals 3.75. Okay, somewhere between the two, which looks basically right. That's good. Oh, I had a lot more working space there. There's loads of questions today. Diagram shows a piece of wood in the shape of a cuboid. Piece of wood is 3 centimetres by 20 centimetres by 1.2 metres. The mass of the piece of wood is 8 kilograms. The piece of wood will float in seawater if the density of the wood is less than the density of the seawater. In a large pool, 1 litre of seawater has a mass of 1,030 grams. Will the piece of wood float in this pool? You must show how you get your answer. So, diagram shows a piece of wood in the shape of a cuboid. The piece of wood is 3 centimetres by 20 centimetres by 1.2 metres. So I'm going to need to change everything to centimetres, I think. the mass of the piece of wood is 8 kilograms. So this is just about getting standard units that I can compare. So I'm going to work with grams per centimetre cube. So volume of the wood is 3 by 20 by 1.2 metres equals 120 centimetres times by 100 times by 120. It's got 3 times 20 times by 120 equals 7,200 centimetres cubed. Okay. Mass of the wood is 8 kilograms, which actually times by 1,000 is 8,000 grams. So the density of the wood is density is mass over volume. So mass is 8,000 divided by 7,200. Always check these things because it'd be easy to get those the wrong way round. So we've got 8,000 divided by 7,200 equals 1.1 recurring. Okay. Now, in a large pool, 1 litre of seawater has a mass of 1,030 grams. Well, so let's do the volume of the seawater is 1 litre, which equals 1,000 millilitres, which is actually 1,000 centimetres cubed. That's a nice conversion from millilitres to centimetres cubed. The mass of the seawater is 1,030 grams, and the density of the seawater is 1,030. Oops, 1,000. Let's just rub that out. Is 1,030 divided by 1,000, which is 1.03 grams per centimetre cube. I should have put that up here. It then says, well, the piece of wood will float if the density of the wood is less than the density of the wood. So the density is not less. So density of wood is more than seawater. So will not float. Now that's, when you look at these questions, that sort of makes me think that something's wrong, because I would probably have expected wood to float in seawater. Just checking that. Yeah, those calculations are right. Yep, the calculations look right. We'll have to go with it. So the answer was, will not float. Yeah. Okay. Here are two solid spheres, A and B. Solid A is made of gold, solid B is made of silver, solid A is radius 2 centimetres, solid B is radius 3 centimetres, gold has a density of 19,000 kilograms per metre cubed, silver has a density of 1,000 grams per metre, which has a greater mass. We'll show how you get your answer. Okay, so once again, this is just about conversion of units. So what we've got here, so let's do what we got. So we've got A, we've got B, we've got density, we've got mass, and we've got volume. Gold has got, so this time let's just always check our units. So gold is 19,000, and this is, just remember, kilograms per metre cubed, and the silver has a density of 10,000. Okay, so this is going to be about the volume. So volume's nice, so volume of A is just 4/3 pi, radius is 2 cubed, so I've got 4 thirds pi, pi 2 cubed. That gives me 33.5 centimetre cubes. And then the volume of B is 4/3 pi 3 cubed, which is, I think I can go back on this. Yeah, we're just going to change the 2 to a 3, which is 113.09. 7 centimetres cubed. So now what I've got, my issue here is that what I've got to do is I've got centimetres cubed and I've got to work to metres cubed. So let's just put this in here, 33.5, 113.097. Right, let's think about a metre cube. Metre cube is actually 100 centimetres by 100 centimetres by 100 centimetres. So in fact, 1 metre cube equals 1,000,000 centimetre cubes. So as such, what I could do here is I could change the 2 kilograms to metres cubed. I could change them into centimetres cubed by dividing through by the million. So if I actually, so divide by, and then divide by a million here, and then I've got centimetres cubed, and so I've got kilograms per centimetre cubed, so 19,000 divided by 1, 2, 3, 4, 5, 6 equals 0.019, and if I've got 10,000 divided by 1, 2, 3, 4, 5, 6, that should be 0. 0.01. Okay, so that's per centimetre cubed. We're still in kilograms. Mass, density is mass over volume. To get the mass, I just times them together. So I've got 33.5 times by 0.019. 33.5 times by 0.019 is 0.6365, and that will be in kilograms. And then I've got 0.01 times by 113.097, 0.01 times by 113.097 equals 1.13097. B, that's in kilograms. B has got the greater mass, and so that is B has the greater mass. Okay. Last question. Here are two solid prisms, prism A, prism B. The cross-section prism A is a sector with angle 45 degrees of a circular radius 10 centimetres. Prism has a depth of 10 centimetres and a mass of 40 pi grams. The cross-section of prism B is a sector with angle 60 degrees of a circular radius 10 centimetres. Prism has a depth of 5 centimetres and a mass of 50 pi grams. Express the difference in the densities of the two prisms as a percentage of the density of prism A. Okay, so that's going to be an interesting one to do at the end, getting the right calculation. So I've got A, B, I've got density, mass and volume. So first of all, so cross-section is a sector, so I'm going to need to find the volume of that, but so it has a mass of 40 pi, let's get that out of the way, and B has a mass of 50 pi. Right, what I've got to do now is work out the volume of these. So the volume's quite easy, because the volume of a sector is volume of the prism is the sector, area of the sector times by the height, and so the volume is 45 over 360, which is the fraction of the whole circle, times by the radius squared, so it's pi r squared, 10 squared. So if I wrote that up here, theta we'd usually call it over 360 times by pi r squared times by 8. So theta in this case is 45, the radius is 10, h is 10. That'll give me that one. Then I'll write this one out over here, which is 60 over 360 pi, radius is 10 again, times by this height of 5. Got a feeling these might work out. So what we got? So we've got 45 over 360 pi 10 squared. Okay, that gives me 125 pi. So the volume of A is 125 pi. That's useful having the pi's there, because they're going to cancel out in a moment. And then I've got 60 over 360 shift pi equals, this one hasn't worked out as nice, it's 261.799. Right, density is mass over volume. So density in this case is 40 pi divided by 125 pi, which the pi's will cancel out, so I've just got 40. 40 divided by 125, which is 0.32. And then I've got 50 pi, 50 pi divided by 261.799, which is basically 0.6 with lots of zeros, so I've just called it 0.6. So I've got all that now. Express the difference. Sorry, that just went off. So I think I've got to this point. So it says express the difference in the densities of the two prisms as a percentage of the density of prism A. So the difference in the densities is 0.6 take 0.32, which is 0.28. As a percentage of the density of prism A is 0.32, so I've got 0.28 divided by 0.32. If I times that by 100, that will give me the percentage. So I see 0.28 divided by 0.32 equals, which is 87.5%. Okay, sorry that went off. I'll try and clip them together.